Animated background.
I do? Yes, I think I might. Yes. I can turn that off if it distracts you, for sure.
No, it's fine.
It's Florida beach, I think. Oh no, Hawaii.
Okay,
Okay. Anyway, what do you want to know? Okay, let's get started at the beginning. Is that okay? If I'm going too slow, you'll speed me up, okay?
sure.
And of course, if I'm going too fast, you slow me down. It's your time and it's your speed. And this is not a one-off. So basically, it all starts with right angle triangles. Okay. And when you
Okay.
do right angle triangles, can you see that picture? Did that happen for you?
Yep.
Okay, good. So we don't need it that thick. Let's see if that's even better. Yeah, that's way better. Okay, good. All right. So I mean, obviously, you know the structure. A lot of things are to do with right angles, and most normally, let's go here. Um, you have an angle, and the angle changes. We call it, yeah, we often use the term theta for the angle. Are you with me so far?
Yep.
And if that is the right angle there, then you basically have to label the sides. Well, one of the sides is clearly the longest. It is the one that is across from the 90 degrees because there's no other angle in this triangle that's more than 90 degrees. Are you okay
Right.
with that? Right, right. So we start with the 90-degree triangle. Okay. So, and if your angle's here and your eyeball's here, you want to keep the OPP as far away as possible. Okay. That's a good example to do if you're in Ontario. Keep the OPP as far away as possible. If I were not sitting with my eyeball here, this would not be the opposite. But since I am, that's the opposite. And that only leaves one more, and that's the adjacent. All right. So obviously, there's going to be there's the hypotenuse. So once you figure out what it is, it might be a five or something, right? Um, the other ones are going to change. The higher the angle, that one of these sides, the adjacent side in this case, gets smaller, and the opposite side gets longer. But if this is five, there's no way the adjacent can be more than five. Are you with me so far?
Yeah, because the hypotenuse is obviously the c squared. That's going to be the longest, right?
Yeah. Well, and that's actually basically because the word hypotenuse means biggest.
Sure, sure.
Okay, so it's the biggest, right? So before we go on to ones where you have an angle of more than 90 degrees, and we have absolute perfect control over this. We're not limited to right angle triangles, okay? But we start with right angle triangles. Is that okay?
Yep.
Okay. This thing you were talking about is a bunch of ratios, and you can figure out if you know any two of the things, you can pretty much figure out the third. Usually they give you maybe two sides and one angle, or two angles and one side, or something like that. And the really nice thing about triangles is when you have that little bit of information, you can tell the rest. It's when you don't have right angles that houses fall down. I don't know if you remember on the way from where we lived in Rosemont to Base Borden, there was a valley, and a guy was starting to build a house, and he hadn't actually bothered to put any it had not bothered to put enough um, triangles in it. Joists, and that's what it was like. I don't know if you
Hmm.
remember the day we came by. I mean, I don't think you were that young. We came by, and this is what the house looked like.
Sure.
Because it's a very windy valley, all right, and the continual wind that was blowing, it actually blew it sideways, and he had no insurance.
Right.
Okay,
So I know triangles make things very strong.
That's what it's all about. All
Right.
right, right. Um, so anyway, some guy a couple of centuries ago, called Napier, he actually went to the trouble of calculating all the angles, all of the possible little decimal degree angles without a calculator that could occur between the 0 and 90 degrees. And but now you have a little thing called a sine button and a cos button and a tan button. And actually, that's not the only three you have, but these are the three most important. So what happens is now, he
Sorry,
said,
and what do those mean?
well, I'm about to tell you actually.
Oh,
Yeah,
okay.
you just give me a minute. Okay, so what? This is where your eyeball is. Okay, if your eyeball was up here, it'd be different. But keep the OPP as far away as possible. Okay, the hypotenuse is always across from the 90. We're going on to ones that don't have 90s, but I can't do everything in 1 minute. And that means that this is Jason. Are you with me so far?
Yes.
Okay, great. Then we have this little name of an Indian princess by the shores of Gitchigumi. That was Pocahontas. This is not Pocahontas. This is sine, cosine, and tangent. And you say, what in the world's a sine? Well, it's two numbers, one divided by the other. So if I had a really, really simple thing, and I'll just use one that actually works, but they all work, but they don't always work as sweetly as this. Okay, do you see this now? You got a 3 and a 4 and a 5. Just out of personal interest, you know that 3 squared and 4 squared is 9 and 16 actually add up to 25. Okay?
Right.
But that's you don't have to bust your chops on that. That's not the important thing. The important thing is this. It's not that so much as the fact that what's the sign? What's the sign of this angle? Oh, I don't know. Yes, you do. Sine is opposite divided by hypotenuse. The sign of the weird little angle, we're going to call it it's called theta. You see that fat little theta thingy there? Is opposite over hypotenuse. And you say, well, I don't know what that is. Yes, you do. It's 4/5. It's 4/5. Okay. So that happens to be point 0.8. Are you with me so far? Uh,
Give me a
Yeah,
second. So
get your
this
calculator out, do your
the
thing.
sine is opposite over hypotenuse. Same with
Exactly.
cosine is adjacent over
Yep,
hypotenuse,
yep, yep,
and tangent is opposite over adjacent.
yep.
So I get that, but this is all in reference to that one angle we're looking for, which you've been
Yeah,
calling
but
DI.
that's right. But you don't always even need to have all of them. But I'm just saying that's what they are. Opposite in this case would be 4, and the adjacent in this case would be 3. Now the point is, even if you didn't have tangent or cosine or anything, but if you even had one of these, you would now know what the angle is. I've never told you what the angle is, but
Well,
you
we have a
know.
right angle in the corner.
Well, yeah, sure you do. But the thing is, this guy 200 years ago, he figured out that if the sign is what do we got here for a sign? Hang on. What did we say the sign was? We said the sign is this, right?
Is that
Four fifths, right?
over
Did you?
hypo? Yeah, yeah, that's right.
Yeah,
Yep.
that's 4/5. Okay, great. So he went to all this trouble. He did a lot of calculations and nonsense. And the thing is, he knows what that angle is, and so do you. If you have a calculator with you now, that
0.8.
it's that is not the angle. The angle is the number of degrees between it's more than 0 and it's less than 90 degrees. It can't be more than 90 degrees. It's got to be some number that the angle is, okay? So that what does this point 0.8 give us? Well, do you have a scientific calculator on you right now or not?
I can, yeah, maybe I do
Well, if
on
you
my
don't,
phone.
let me see. I can get one
No, I
here.
do on my phone. Hang on.
Yeah, but I've got one here too. So if you, what we're trying to do is find out the angle, okay?
Yeah, I've got it.
Okay.
Okay.
Well, here's what you would do. If you know that the sine is a certain
Hmm.
amount, then what you do is that yeah, you'll probably have some kind of weird button on here. Oh, trigonometry, right on. Okay. If you didn't know it was point 0.8, and you did know the angle, you could figure out the point eight, but you got it the other way around. You know that it's point eight, and you would like to figure out what the angle is, and you know that it's more than 0 degrees, and you know that it's less than 90. Are you with me so far? So you can imagine if you have some kind of a structure and it's four up and it's five across, and you want to know what the angle is. Are you with me on that? Well, here's
This
how
is
you do
this
it.
is all based on a 90-degree
Yeah, at the
at the
moment,
moment.
but
Okay.
we're absolutely going to be able to handle all the ones that are not 90, but we have to do one step at a time, dear Jesus. Okay. So what
Okay.
you do is you say, okay, all right, we want the second function, which is sine inverse of, and I'm going to
Yeah.
try it. I
Now
don't
you're
even know.
talking Greek to me.
No, the thing is, okay, maybe we should do it the other way. But the thing is, if you already know what the ratio is, you need to work it back and figure out what the angle is. If you know the ratio, you need to find out the angle. If you know the angle, you need to find out the ratio. Well, let's do it the other way then. It's not a problem. Let's do one the other way around right now, okay? We'll start at the very beginning. It's a very good place to start. Here we go. Ready?
I feel like yeah, I got lost there.
Okay, we're going to get unlost here in a few seconds. Okay, we'll do it the other way around first. Okay, ready?
Okay.
Okay, there's five. Okay, and this is let's say this is 30 degrees. Can you read my writing? Is it too thick? I can make it thinner.
It is a bit thick, but I understand. That's fine.
Well, we can make it thinner, right? All right, so all right. Are you
Sure.
okay? Right, so here we go. Right, so okay, you got a five, right?
Right.
Okay, and we let's say it's a five. What is this? That's what you're trying to figure out. I say I don't know what this length is. Are you okay with that? This isn't not this is a nice 90. We're not getting into the ones that aren't 90 yet, but that was a
Hmm.
nice 90. So the question is yeah, what's the what's that length? You see the question mark there?
My guess would be it'd be three,
Well, okay, that's fine, but
but
you
only
don't.
because we've done what we've done so far.
Yeah, but it's not okay.
Okay.
All right, so yeah, it's not. Okay, so you say, I know this is a 30-degree angle, and I know that that is five. Oh, can you see me pointing, by the way? I can't remember. Can you
Yeah, I
see?
can see you pointing.
Yeah, okay,
Yep.
okay, fine, fine, fine. Great. So this thing, I want to know how long this line is. Okay, I had a big question mark here. Okay.
Okay.
How long is this line?
Yeah, not a
Okay,
clue.
not a clue. Awesome. You will in about 2 seconds. Did you say you now have a scientific calculator in front of you?
I do.
All right, then you're not even going to have a problem with this, right? All right, so uh, okay, I can't make that a wee. I want to make it a wee bit. No, it don't matter. Don't matter. Okay, fine, fine, fine. All right, great. So now that you're sitting here at the 30, what is the name of this side? It'll have one of three names: opposite, adjacent, or hypotenuse.
Yeah, that's the opposite.
That sure is. Keep the OPP as far away as possible. Where's the hypotenuse?
It's the long one, the five.
Okay, okay, right. You don't really need this. You could find it. It wouldn't be that hard later on, but we're not interested. We say, by the shores of Gitchigumi. Here's just a little Indian princess here. Okay. Okay. So what is this? What, which one of these things, sine or cosine or tangent, involves opposite and hypotenuse? Which one of the three? It's not all three. Are we going to use the sine or the cosine or the tangent? You have to look for the ones that have these words in them, O and H.
Right.
Which
So we're talking about, yeah, the sign then.
excellent work.
What,
Sine
okay.
30 degrees equals. Well, what is O? And you say, I don't know. Okay, put a letter down. It doesn't matter. Oh, what is H?
Hypotenuse.
Well, what is it?
It's the length of,
Oh, I mean, you can see it on the
Right.
picture. What is the hypotenuse?
Oh, 5. I see what you're saying.
Right, right, right. Great. And you say, oh, I wish I knew what the sine of 30 degrees was, eh? Well, why don't you ask your calculator? I'm going to try to get
Okay.
this. I've never used this calculator before, so I don't actually know how it works.
So how do we punch this into a calculator, scientific calculator?
It depends which calculator it is. Okay, so yeah, all right. I don't say some of them. Okay, hang on. I've never used this calculator before, so just give me a second. All right. So it's trigonometry, and some of them want you to punch the number in first. And in this case, the number is 30. So oh, and there some of them are not even set up. Oh, I'm mod. Okay, hang on. What's the mod? No, no, no. Oh, that was important. Degrees, and they want it in degrees. Okay, fine, fine. Okay, so it's 30 degrees. So some of them want you to punch it in first, 30 like that, and then push sine,
Okay. So
which is sine.
mine says sine and then brackets 30
Yes, that's beautiful. Hit enter.
equals
Yes,
negative 0.98.
right on. You're in radians. That's not okay. You need to be in degrees because we're functioning in degrees right now. So I just had to change my calculator
Hey, I'm
because
in
you.
degrees now.
Okay, try again. Sine of 30 degrees equals.
Okay, hang on. Sine of 30
Yeah,
equals
yeah,
uh 0.5.
yeah. Do you see 0.5 on my screen as
Yes, I
well?
do. Yeah.
Okay,
Yep.
great. So that's right. So this guy, 200 years ago, he figured out that 0.5. All right.
Okay, hold on a minute.
Yeah, I'm not going anywhere.
How did you know any of this was right or wrong?
What do you mean, right or wrong? If you know
Like
if you know
the
that the angle is 30 because you measured it, and you
no,
know
what I'm
this is
asking is how
5,
did you know how did you know that the calculator was off? Like,
what? Okay, because 200 years ago, a guy named Napier, uh, he actually worked them all out because he knows that you were telling me a minute ago that triangles are rigid, that you can't just randomly throw together three pieces of wood. Okay. If the three pieces of wood form a triangle, it doesn't come out to a whole bunch of random, oh, I don't know. Oh, I don't know. It could be any angle. No, that's not true at all. If you take a stick that is 5 and you take a stick that is 4 and you take a stick, oh, that's a 3 actually, and you take a stick which is 4, and I tell you to tack them together, go on, put them together, make something, right? You're not going to have any choice. You're not going to come up, oh, well, I'm going to make one with 80-degree angles. No, you're not. Three pieces of wood tacked together will always make the same thing. Okay. If for this one, it happens to be a 90-degree. They're not all 90s, of course. But the rigid thing about um, triangles is it will be one thing. It won't be two choices or seven choices. Okay. So when we figure out, as soon as we know that the angle is 30 degrees, he worked out and he worked out what it would be. He did like 200 years ago, and it just so happens that it's 0.5.
and so what is the significance of point 0.5?
Well, it's going to tell you the answer. That's what's the good news, is because now that you know that 0.5 is, remember a minute ago you said, oh, I don't know, I think that's 3, right?
Sure.
Do you remember saying that? Yeah.
Yep.
Well, now you don't need to say that because now you're going to know. Well, that's not a very good color. Okay.
And what are we're
Here.
talking about the length?
Yeah. What's the missing?
We're
How
solving for
how tall?
opposite.
Sure, you are. Yeah, you're trying to find how tall is the building. Okay, it's not very tall, but anyway. So what you did is, if there happened to be a guy wire going down here, and you happen to know that this cable was a tower. It'd be more likely a tower than a wire. And you knew that this guy cable was 5 meters long, okay?
Okay.
And you don't want to bother to go and climb the building or measure the building or run a tape measure down it.
Right.
So what you do is you go back until you get a 30-degree angle, which is really easy to do, even with a simple little. We get kids to do it all the time. What you basically do, you may have heard of them before. It's called a protractor,
Right.
and you basically attach a string, and then you have look all the way up, and when it reaches 30 degrees, you say, "Oh, I'm stepping back until it's 30 degrees. How tall is the building?" And you didn't never touch. You never went up the building. You never climbed the building. Okay. And all you did is you paced back a certain amount, and then how tall is the building? Okay. And you know without a doubt how tall this building is because this guy, the calculators basically are copying what he did 200 years ago. The sine of 30 degrees is not zero point 0.5 some days and zero point 0.7 another day and zero point 0.3 another day. It's 0.5. You can trust the calculator, or you can trust Napier on that. He got it right. Okay. Are you with me so
Okay.
far? So I want to know how tall this building is in meters, let's say. Well, you know now because what you do is you remember doing that with the five. Have you ever done that before with a five? Did you see where I'm waving?
Yeah. So you're talking about because that's 30 degrees
Yeah. Yeah. We know it's 30 because
and
we
you're
measured
solving
it.
the sine, which is the opposite over the hypotenuse. So
Yeah. Yeah.
we're looking for the x
Yeah.
over 5.
Yeah.
And
Yeah.
then
And how do you get this five out of the basement? What's the opposite of dividing by five?
multiplying by 5.
You better do that to both sides then. Hold on. I need to make
Where
that.
are you? I'm kind of lost you here.
Well, hang on. I'm trying to make this a little. There we go. Can you see the screen clearly?
Yeah, I can see it better now. Yes.
Right. Okay. Great. You can see it, right? Okay. So we know that point 0.5, which is the sine of 30 degrees, we know it because we pushed the button on a calculator or we looked at a 200-year-old table. We know that it's point 0.5. And we know that X is the missing information. And we know that 5 is known to us. Okay. So then you say, well, what's this? What's that? Well, there's a little thing about equations. If you want to find out what an equation is, you want to get the x by itself, the unknown all by itself, you need to multiply it by 5. Okay. But when you multiply one side by 5, what are you supposed to do with the other side?
Or you got to divide it.
No, you do the
Sorry,
same on both
multiply
sides.
one side, you
Yeah,
multiply the other. Sorry.
exactly. So here we have the 5 on the bottom and the 5 on the top. They're going away now. They're not there anymore. What's
Right.
left on this side? The unknown, right?
Right.
Well, what's on the other side? What's 5 times zero
5
point 0.5?
multiplied by 0.5.
Yeah, what's 5 times a half? Hmm.
Yeah,
What's,
2.5.
yep, that building is 2.5 meters high, guaranteed. So what you just did without actually measuring it, you found out something. And so the first part of Sokotoa, before they get into all the ones, and they really do work well with all the ones that are not uh, perfect right angle triangles. But basically, you need some practice. That's all. And there's never a mystery about it in the sense that
So,
I could
can I
throw
ask
anything
you a
at you now.
question?
Yeah,
How did we know to use the sine versus the cosine versus the tangent?
love it. Absolutely. Depends where your eyeball is. Okay. That and
Okay?
as long as you know that and you're good with that,
Right.
you're right. So here you are. You're standing at the top of a building. All right. You're up here somewhere. I can't even draw it anymore. There's you.
Okay.
And
And
now
your
you're
eyeball's
looking
up
down.
there.
So your eyeball's up here.
Okay.
All right. So now you know what the hypotenuse is.
Um,
What's this one? This is the hypotenuse, right?
are we assuming that's 5 again?
No, it can be anything. We don't know what it is. But we just you wanted the labels. That's all.
Right. Sorry. Are we solving for hypotenuse or are we
Later we'll solve for
okay?
something. It doesn't matter. But right
Okay,
now, we needed to know which one to use. Okay. Right now,
sure.
you don't know which one to use. Okay. But all I'm asking you is, are you totally convinced that that's the hypotenuse?
Absolutely.
Great. What's this side here that I'm waving at?
Opposite.
This one?
Adjacent maybe?
It's adjacent. But look, his eyeball's up there. And you want to
Oh, and keep it
keep the
away.
OPP as far away from me as possible.
Oh, I see.
Okay. And then that
So
makes us
the
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 efficient.
opposite is in relationship to where the eye is.
Yes, absolutely. Right? Great.
Okay,
So now you could not solve this question yet. Okay.
right.
You wouldn't know yet. But then what happens, there'll be some giveaway, some thing. Here's a good one. And we'll do that one. Okay. So here's the story. As you look down, let's suppose that you've got a cheap little protractor or whatever, and you happen to notice that this is 40 degrees.
Dad, can you give me half a second?
Yep.
How do I mute myself? Hang on.
Yeah. Okay.
Sorry about that.
No, that's all right.
Where were we?
Okay. So you're on the top. You walked up and you're at the top of this building. All right.
Right.
Right. And it just so happens that this time you actually walked up the stairs and you know what the height of the building is.
Okay.
This is a 10-meter high building. Okay. Right.
Sure.
And what you're supposed to do is you're supposed to attach a support. Maybe it's a sign or something, maybe not a building, okay? It's,
Right.
okay, let's say it's a sign or something. Anyway, I don't know how you got up there. Just be careful. Make sure you use a ladder and safety gear. Okay, so, and the thing is, you need cable, and the cable's got to reach from here to here. And
Okay.
this cable is really expensive, okay? Like it's $30 a foot, 100 centimeters. It's a lot of money, right? So you need a cable that stretches from here to here. And all you know is that the height of the building is 10 and this is 40. You don't even know how far you just know that this has to be because this is a sidewalk. And you can't be putting the cable any closer. So the cable's got to be this long, and then you better allow yourself at least 50 centimeters on each end for tying it. Okay.
Sure.
But let's not worry about the 50 centimeters yet. So the question is, how long is the cable? How long is the hypotenuse? That's the question. How long
Hmm.
is the hypotenuse? Right? Okay, so you take it calmly. And you want me to start? I could start
Well,
now.
it'd either be, yeah, so we're gonna use one of our formula.
We sure are.
And that's my question is how do we know which one to use?
Well, that's a wonderful question. Um, what is the stuff we know? We
We know the
know
hypotenuse, we know the angle
you do
of,
not know the hypotenuse. You
sorry,
need the
sorry.
hypotenuse. You
We
want the
know the
hypotenuse.
adjacent
That's
height
that's all you know.
and we
And the
know the
angle.
angle.
Right on. You do not know the hypotenuse and you want to know the hypotenuse,
You're right.
right?
You're right.
Right.
Solve for the hypotenuse.
So when you write the word, and we're going to write the word,
Tangent. Oh
um,
no, wait. We're looking for the opposite sign. We're looking for the sign.
you're not interested in the opposite. You want this cable length. You got to buy a piece of cable.
But wait a minute, we already know the adjacent,
That's true. You do.
so we're trying to.
What is the thing you want? What's the thing you got to go out and buy?
Hold on a second.
You're trying to buy a piece of cable, okay?
Fine. What I'm asking you is this:
Yeah,
we're going to use this formula, right? One of these three formulas.
absolutely.
SOHCAHTOA.
Yes.
And so we already know one variable within the formula here, which is the length of the adjacent
Right.
side.
So do you see these two words here?
Know and want.
Yes. So they always, to know what part of this to use, you say, what do you know and what do you want? Tell me what you know and tell me what you want. In
We
terms of
know the adjacent,
yes, that's an A. Remember that. Don't forget it now.
right?
What do you
Yep.
want?
And we want the hypotenuse,
Oh, you want an H. You
right?
know an A and you want an H. Now you look at this word and you say, where does there occur together an A and an H?
Cosine.
That's how you choose. So you say, okay, fine. Cosine, 40 degrees.
Hold on. Say that. Okay. Run that back to me again.
Of course. Of course.
Know and want.
Know
And
and want. It's
so,
always know and want. Okay. What do you know? What do you want? Okay.
and what you know is the one, and what you want is the other. And then
Yes. Yeah.
that
That,
is the reason you solve for whether it's tangent, cosine, or sine.
yes. Okay. So let's solve it now. Let's find out how long the cable is. Can I move the picture away now? A
Yep.
little bit. Okay, great.
Yep.
And don't forget, add an extra 50 centimeters on each end for the
Well, we're
time.
not going to do that,
Yeah, all
but
right. But don't worry about that. Okay,
sure. So
great. So
cosine is that 48 or 40?
it was 40 actually.
40. Okay. So cosine of 40, and we know the adjacent is 10.
Hold on a second. That looked more like a 40 to you? Okay,
Yes.
so what is the cosine of 40? You have to get your calculator working now.
40 cosine equals
Yeah,
0.76.
that's reasonable. Yeah. Try to give yourself a couple of four. I don't know how many decimals. It's usually good to give you four, but you go ahead.
0.7660444444
Oh, okay. Oh, that's
332.
fine. That's fine. 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 All right. And then what did you say the adjacent was?
We called it 10 meters earlier, right?
Okay. Yeah. And what did you say the hypotenuse is? Don't know.
We don't know the
You can
hypotenuse.
give it any name in the alphabet you want, but we often use X.
So we're going to say cosine of 40 degrees is
Six.
0.7660.
Yes.
And we're going to take that away from that side and add it to that side. So we're
Well,
going to
it's not so
multiply.
much at oh, good for you. Yes, it's multiply.
So
Yeah,
we're going to
that's
multiply
you got
0.76660 by 10, which is
not by
actually
10,
pretty.
not by 10. We're going to multiply by X.
Hold on.
Maybe I shouldn't use X. Hold on, hold on. I will not use X, okay? I'll use H or something. Wait a minute. Hypotenuse wasn't that's way too thick. I'll use um I'll use the letter H.
Sure.
Okay. The H is on the bottom.
Yeah. So then we have
And
to
get it on the
bring it from
top.
the bottom. We have to move it to the top. So
That means you're going to
you divide
multiply.
it by the bottom on the right side, and then
You
you multiply it on the other.
you always do the same
H
thing.
is equal to,
You do the same thing to both sides of the equation. If you multiply one side by H, you multiply the other side by H.
what
Okay.
happens where you, oh yeah, maybe I'm getting that confused.
Yeah, no, always do the same thing to both sides of the equation. Now, what happens when you
Right.
multiply this side by H, the side
What
with the
was I
10?
thinking there? I don't know why I thought that.
Well, you're trying to do two different things and you're doing a thing called cross multiplying and it kind of works, but let's take it
Right.
one step at a time. So there was an H on the bottom, so you wanted to cancel it out. Did you see that I just canceled it out?
Yeah. So now it's
It's
10
just
is equal to H
it,
times.
no, there's no H's. It's gone.
No, no, no.
They're
It's still
gone.
H times 0.7660.
Oh yeah. Oh, I agree with you. Yeah. Yeah. Sorry, I was not on the right place. Great. There you go. So now you know that H is 0.7660. Right on. Point
So
H, oh,
hold
sorry,
on, and
point
now,
7. Yeah, yeah, go on, go on.
now if we were to take and move that 0.7660
Oh,
across,
right on. How do you move it across? Do you just bring it across or do you?
well, you have to do what you do to the one side, you do to the other.
You're
So,
absolutely right. So I'm going to take that nasty
and
0.7660
divide it.
and I'm going to do both sides by 0.7660. I can't do something to one side without doing it to the other. Yeah. Now, what this is where your part came in that you were trying to tell me. What was multiplied on one side becomes divide on the other. That's what you were
Right.
trying to say. And you're
Yeah.
right. What is 10 divided by 0.7660?
Uh,
Just,
move the decimal place over.
yeah, you're dividing 0.7660 by 10. And that's not what it says. It says 10 divided by 0.7660. Let me put it to you another way. Just give me a second here. Are you with me? Do you see
Yeah,
the
I'm
original
rusty.
diagram? Do you see this original diagram?
Right?
Do you expect this hypotenuse to be shorter than 10 or longer than 10?
Longer.
You better be. Okay. All right. And if you, yeah, so take and you put in your calculator 10 and then use the divide sign and then 0.7660.
Right.
You got that? You got a calculator with a 10 divided by
Yeah,
0.7660.
13.054.
Oh, okay. Okay. Does it seem reasonable that it would be that? 13 point, what did you say?
0.054.
Sure.
Yeah, I think that's reasonable.
Yeah, it wouldn't be reasonable if you did it the other way around. If you took 0.76 and divided it by 10, you wouldn't be in the right place. It has to be longer than 10.
Right.
Okay, so now you go, yeah, okay, so I got to get a 13-meter cable there, $30 a meter, so it's pretty expensive. There's no way you want to come back to the boss and say, I ordered 10 meters of cable. I thought it might work. On the other hand, you don't want to say, oh, well, I ordered 20 meters of cable.
Right.
That's government workers. They would probably order 20 meters of cable. But
Sure.
you want to pretty much get it right. So you want to get 14 meters of cable, maybe.
Okay,
And that,
let's do another one.
do you see what you're doing though? It's
Yeah.
it's
Do you
it's
have time?
I yeah, I have another 10 minutes. And then of course we can do more later and I'm recording this too, by the way.
Okay.
So and I'll send you the recording after. Okay? So yeah, and they're all like this. But right now we're doing the ones where you know the angles. Okay. I can do another one where we know the angles, but then we have the next time we meet, which might be in 3 hours or it might be tomorrow or something. I don't know. But right now we're doing the ones where you know the angle. We also need to be able to do the ones where you don't know the angle and you got to find it. Okay.
Right.
Okay, that's fine. So here we have another whole right angle thingy going on, um, like so. And now the nice, well, just a second. Yeah, okay. You wouldn't get many of these because it would work with Pythagoras. But just yeah, I really want to tell you about the other thing, Dave. I really do. But okay, hold on a second. Okay, I'm going to call that a 4, and I'm going to call that a 5. Right. No, I'm not going to call it a 5. What am I talking about? Don't know it. Okay. Don't know it. Yeah. Yeah. This will work great. Okay. So anyway, um, yeah. The thing is, I want to make a real. Oh no no no. This is fine. Hold on.
10 of
Was that too?
45.
Yeah, it was a bit too thick, wasn't it? Yeah. Sorry.
Okay.
Actually, you don't want to use 45 because that's a trick. We'll use something else. There we go.
Okay.
Okay. So the thing is, how big is this? Okay.
Where's our angle? What are we looking at?
Where your angle is where I just said it. This is where your eyeball is. Your eyeballs,
Your angle is always on the eyeball. Like that's the
absolutely. Yep.
okay.
Your angle's where the eyeball is.
Okay,
And
so
the whole show
we're looking for the opposite then.
oh, very good.
Um, hypotenuse and adjacent. So
No
if we
want.
know and want, we are looking for the opposite.
Yeah. What do you know?
We know the adjacent.
Okay. You don't know a thing about the
We
hypotenuse.
want the opposite.
So by the shores of Gitchigumi, write this route down again.
So we know the adjacent. We want the opposite.
Go to the part of the word that has
Oh,
those two things.
tangent.
Yes. Tangent. So you go the tangent of 47 degrees equals the opposite over the adjacent.
So 47 multiplied by 10 is
Not multiplied by not
1.07.
yeah, it's not multiplied by.
Well,
It's
does
a
it not do
function.
that? It goes 10 and then 47, but the
Yeah, but
47
they're not
doesn't.
multiplied. It's a tangent of. It's a function inside the tangent, but that's okay. You got it right.
What does that
One.
mean? Function inside the tangent.
Well, you're not multiplying it. Tan is it's nothing. It's just a word. It says what would be the ratio if I had 47 degrees? That is not the same as saying I'm multiplying something by 47 degrees.
So this is where I'm lost here because I think like is
You
tangent not like a curved line where it intersects with a straight line or something?
know, it it's a magical thing that was figured out 200 years ago in actual detail. And
Hang
then they
on, I
turned
looked
it
this
to a
up.
calculator so that anytime you know that this is 47 degrees and you push the 10 button, you're going to get a weird number.
Okay, hold on. So I understand that you're saying this, but when I was looking into this earlier, it was literally a definition that came up as a straight line or plane that touches a curve.
Oh, yeah. Oh, that's a mathematician going full blast. That's a whole because we use things for different meanings. This is a tangent. It has nothing to do with trigonometry per se, but it's just a tangent line. It only just touches the curve. That's a whole different thing. So, what you could have asked though is what a tangent ratio is, and then it would have probably said opposite over adjacent or something like that.
Okay, so
Yeah, we use the
this
same words for.
tangent is very different.
Oh yes. hmm
Okay.
Technically, no, it's not because if you, what they do is they never mind, but because they're going to make some kind of a thing eventually, and the blah blah blah. But going through the center of the yeah, this tangent and the one we're talking about here today and right now is quite a different thing. So get your calculator and tell me what the tangent of 47 degrees is. And it'll be the last
Okay.
one I can do for you. What is the
Okay.
tangent?
It's
One.
1.07.
Okay. Okay. That sounds pretty good. And then what is the opposite?
We don't know the
Don't
opposite.
know. So give it a letter name.
Oh,
Sure. Just so long as you don't think it's a zero.
yeah.
Okay. Yeah. And then what's the
And then
adjacent?
4.
Right. Now, this is a little simpler one because you don't have to do a double up and a double down like you did on the last one. I'll actually call this OPP, okay? Right, just for fun.
Right. So multiply
That's
4
all you
by
have to do.
1.07.
Yeah, that's all you really do. You multiply this side by 4 and you multiply this side by 4. Remember, truly, I know what you like to do that shortcut, and you're not wrong. Where it's dividing on one side becomes multiplying on the other. But really, you're doing the same thing to both sides. Are you okay
Right.
with that? So what happens to the 4 on this side? Can you see me
Um,
wiggling? Can you see me wiggling here?
yeah,
What happens to the 4 on this
it
side?
just gets canceled out.
Make the bad man go away. Okay. Yeah.
Right.
All right. So it's OPP all by itself. What's this?
Right. And then so it's 4.28.
Yep. Meters or whatever.
Right.
And that's all I can do right now, Dave, because the guests are coming.
Okay.
But I can absolutely do more later. I'm going to record this and then I'll send it to you and then we can pick it up from here. There's a
Okay.
lot more to do, but it's not insurmountable. The next thing we'll probably do is, hey, what happens if you don't know the angle and you're trying to find the angle? Okay. Well,
Okay.
we got it covered. We'll easily be able to do that, but not right now. Is that okay?
Okay.
All right.
Thanks for
Talk
your
to you
help.
again. All right. Bye
Talk to
bye.
you. Bye.